all. Welcome to this Ferro Talk show number 13, organized by Ferrocement Society of India, Pune. Our today's presentation is a very special one. I would say so far in last 12 episodes, we have heard from basically the engineers who are working in ferrocement field. But today we have an renowned architect here, Mr. Kalamdani from Pune, and his wife, Anjali Kalamdani. Both are architects and both are working through their Kimaya organization. For a brief introduction, I would like to present him. He is a senior architect in Pune. He has used this ferrocement technology for many structures. He is an expert architect and famous for particularly the restoration of heritage structures, for which he has got the recognition around the world. They have a firm in Pune named as Kimaya Architects, and his speech and the presentation on ferrocement is worth watching, especially by the architects. Uh, I would like to add, and it is a proper here to mention that both Mrs. Anjali and Mr. Kiran Kalamdani are the authors of the manual for non-conventional and innovative construction techniques that was released by Dr. Paramasivam during the International Ferrocement Conference in Pune. Both are life members of our Ferrocement Society, of course, and they are very actively involved in all the activities organized by the Ferrocement Society. With this introduction, we all are eager to hear from him the excellent presentation, how the ferrocement technology can really nicely be used and promoted, particularly by the architects. So, over to Mr. Kiranji.
Today's talk I have entitled it as Ferrocement at the Service of Heritage. Since we do a lot of work in conservation of heritage and architecture, I would like to start with this bungalow. It's a bungalow premises in which we did some ferrocement work starting in 2017 and ending somewhere in 2020, late 2020. Now, this bungalow is called Rollstone, and it is right behind AFMC College, which is on Solapur Road. So, in this work, we were ably assisted by the consulting engineer, who is also a Ferrocement Society member, Mr. Bhalchandra Bedasgaonkar, who did the structural design for us in this particular job. And of course, there is Prakash Nagnath of Habitat Ferrocement, who did a perfect job of contracting and coordinating between all of us as agencies trying to make it happen. The property is called 4 Prince of Wales Drive, Rollstone. That is the name given to the property. And it is a heritage property in which we had to do this work. So let's go and see what actually was done there. This was built in 1827, just after the British had taken over Pune. And this was actually the home of a cavalry lieutenant general. And what you see in this picture is his bungalow. It's a large bungalow set in a 4-acre plot. And the bungalow is about 10,000 square feet. And the ferrocement work that we did was an elevated water tank, a ground level tank, and a sewage treatment tank. All these 3 were done in ferrocement, and which is why I'm sharing this work with you. I'm not sharing any of the conservation work that was done, obviously, because we are all Ferrocement Society members and we have all gathered here around our screens to see this. Next, please. Yeah, that's a Google Earth image of the property. You can see that it's an abundantly wooded site, and it's a 2014 image of a Google which shows everything in verdant green color. And these 3 positions are marked. The bungalow that you see somewhere in towards the right hand middle of this plot is the elevated water tank. Then you have a sewage treatment plant on the towards the east. The north is on your left, and the ground level water tank. That's the third structure. So we'll just talk about these three structures today. Next. The owner was very fastidious and said that we need to first check the Vastu of this site. So there you have a Vastu diagram, 8 squares by 8 squares, 64 squares with a Brahmastan in the center. And the pink bungalow, which you see, the oriented northeast, southwest, that's the bungalow. And the position of the water tank in ferrocement is shown there, which falls in the southeast quadrant of this particular Vastu diagram. So that was a little kind of some might call it superstition, some might call it continuity of traditions, whatever. But since they were keen that we follow this, we had taken a Vastu consultant, one Mr. Kelkar, who guided us on this. Next. And there you see, that's the plan of the bungalow with the position of the water tank in ferrocement shown on the right-hand top corner. Next. That's a detailed kind of a site plan showing all the trees and all the service lines and things like that, and the exact location and size and position of these three tanks. Next. Now, this is even after the tank was built, you can barely see the tank. And one of the successes of this particular conservation project was that though a lot of new amenities and services were added, hardly any of them are visible on the outside. Because since it's a conservation project, the owner did not want all these modern services to be obviously apparent anywhere in the elevations or in the most public views of the building. That's the bungalow with a wide veranda in the front and all these arches in brick and lime stucco. Next. That's a site plan showing you the contours. So the bungalow is placed on the highest part of the site, and the site sort of slopes towards the northeast and the north. So according to the Vastu also, it was an ideal location. And the three locations that you can see of the water tank here, the sewage treatment plant over there, and the ground level water tank here. There are some notes that have been made on the design. It's about a 3,500 liter overhead water tank, which is at about 6.75 meters height above ground level. This is because you needed pressure to come, when the water comes down. She needed sufficient pressure in the bathroom that was there on the first floor, which is on the front side of this bungalow. And the ferrocement design concept was that the water tank is octagonal in shape with a flat bottom and a sloping roof. And since it is nearer to the circular shape in its form, the reinforcement is designed like a hoop stresses coming after filling the water inside the tank. The wall thickness of the ferrocement tank is 4 centimeters. It's about very thin, and the bottom is supported by the middle over circular hollow shaft. So outer 8 corners are supported by 8 inclined 4 centimeter thick ferrocement stiffeners from the center shaft, each supporting the corner of the octagon from the bottom. And these stiffeners are acting like cantilever beams having a maximum depth at the center shaft. Circular column shaft supporting the water tank outside diameter is 80 centimeters, and it's a long thin cylinder, and it's originally designed for a height of 6.75 meters and 4 centimeter thick. Originally the stiffeners were 15 centimeter wide and 4 centimeter thickness, and are provided at 1.5 meters center to center from the shaft. Let's go to the next one. There you see a kind of a 3D SketchUp view of the water tank balanced on that central shaft over there. And inside the circular shaft is a 50 centimeter wide opening. So you go through that opening to clean the tank, to check if the water is properly coming in or it's dirty or needs cleaning and things like that. and the opening is kept as minimum as possible, as this becomes the weakest section, having a maximum moment in the case of an earthquake. The sectional profile of this weakest section are worked out for analysis, and the design is checked for actual loads coming from the fully operational water tank above and the moments caused due to a possible earthquake. The stresses in ferrocement of the shaft at this level are have kept this column within permissible limits, and they are assessed in ferrocement as a composite material. Stresses in steel armature meshes and stresses in concrete are difficult to determine separately. So there is help from Dr. Bedasgaonkar in this one for the design. Next. There you see some of the diagrammatic drawings of this, which were earlier made. Earlier, the tank was not so high, but later on we had to increase its height, resulting in some redesigning in this place. So that's a detail of the solid bracket, which is 1.4 feet tall and about 2 feet, a little more than 2 feet wide. Next. So the modification in the original design that happened, where the client needed to increase the height of the tank by about the shaft is done for a height of approximately 2.5 meters from the level of its foundation. The entire reanalysis was carried out for increase in height and the self weight of the shaft, and there's a considerable increase in the moment at the weakest section where one enters the shaft. It is evident that the section needs to be strengthened. So the vertical shaft is strengthened by adding 8 vertical stiffeners of 20 centimeter width and 4 centimeter thickness all along its height. The circular horizontal stiffeners originally provided from inside are now brought outside at every 1.5 meters for lateral strengthening of these vertical stiffeners. And the vertical stiffener added moment resisting capacity that was necessary after the increasing in the height of the water tank. The footing was also modified for increased loads and moments. It necessitated casting a new footing over the existing footing, and the desired area around the existing footing was excavated until the strata on which the original footing is cast. The increased area around the original footing was filled with plumb concrete for complete bearing, and the new footing of the increased area and design reinforcement is cast over the top of the existing footing. The reinforcement for additional stiffness provided for the staff is started from its new foundation. So Mr. Prakash Nagnath had to do a bit of, reworking especially at the foundation stage when we had to increase the height of the shaft. Next, please. There you see there is a door from which one enters into that, and it's an elevation of the door. Next. There you see height up to from ground up to apex is 8.97 meters. Depth below ground is 1.95 meters. And that's a section showing you the ladder in the center, which goes right up there. And then the water tank, which is like a little house perched on the top of a pole. Next. There's a detail of that water tank over there. It's about 1.44 meters right up to the bottom of the overhanging eaves that you see, the cover. So one has to go right through the staircase up over the roof, and there is a opening from which you get down. And for cleaning the tank, the man moves around the shaft. Okay, and there is a kind of a grill over the central ladder through which the person can go up. So it's a tight space, a little claustrophobic, I might say, but the cleaning person doesn't mind it. Next. Yeah, that's a detail of the shaft showing the stiffeners that were earlier inside, but later were taken outside. Next. That's the footing going 1.95 meters below the ground. Next. It's like an M20 concrete footing, and that's the detail of the roof plan. There you have those 8 radiating arms, which are actually brackets supporting the roof, the ribs for supporting the roof. There's an MS grill in the center. There's a stiffening beam around the central opening over there, and then the opening for the access to the water tank, which is seen right here. In one of the quadrants, you have an access, a mild steel tower. About 3.28 by 3.28 is the kind of outer size of this uh, roof. Now here you are seeing the tank at the level where the water actually stands, and the outer one is the roof that projects over it. So since most of these structures in this entire campus, they have this sloping roof and they have these overhangs, wide overhangs, almost they're about 2 feet, in excess of 2 feet from the actual body of the water tank. So water tank is like a donut with a hole in the middle and 8 sides all around. Next. Yeah, there you have the detail at the ground floor where the entry door is there and there's an MS ladder. Though the shaft is shown as octagonal here, it was finally built circular with the ribs. Next. Yeah, there you have the octagonal shaft shown there. So various level to understand now. Yeah, please go ahead to that. To understand the reinforcement, so that there is no confusion in the stage of the construction. All these stiffeners, with the lap length of 15 centimeters, and each bar and each little wire and everything was drawn to scale to understand the complexity of this whole thing. Not only for the ferrocement contractor, who was actually an experienced person, but there was some training that happened on the job. There was a trainee architect who was working on this, and she had not worked on ferrocement before. So for her to understand what is happening, we made her draw each member of that particular water tank in detail. So the meshes, the 6 mm diameter rings at 30 centimeter centers, the 4 numbers, 8 bars, all these were drawn to scale, and she was asked to go and check these things on site. Next. Yeah, there you have the section through the base slab and the side walls, including the overall thickness, the number of bars and meshes that go inside it, the octagonal outer wall, base slab. All of these have been shown in this one. That's a plan detail showing you the angles of the octagonal water tank above. Next. Details of the shaft skin, hexagonal mesh outside, weld mesh inside, in the 18 numbers of 12 vertical bars, 8 rings. All of these have been shown here to scale. Next. Yeah, the solid bracket supporting the water tank, that has also been shown here. Next. This is like the revised drawing that was done after the excavation had happened. You can see in dotted line the older side of the footing, and this is the newer side of the footing. Yeah. Next. There you have the shaft, which now became circular, and all these stiffening sort of reinforcements all around it that you see, and with the vertical stiffeners at every 1.5 meters height. Next. Now the construction started somewhere in April of 2018. A very hot month actually to start construction, but we had no choice. There you have the footing finally, with the shaft going up and the main reinforcement bars of this shaft. Next. There you see now there are the weld mesh goes on both sides of the shaft, inside and outside. Chicken mesh and weld mesh both on both sides. There you have the shaft seen from a different angle. Another detail. 19.4, the whole reinforcement goes up. 26.4 is when all the weld mesh and chicken mesh is on place, in place. Somewhere around 2 months later, you have half of the casting being done. Here you can see the outer ribs, the stiffeners at every 1.5 meters. There you have the base, the door from which one goes inside. Uh, and then when it was complete, of course, there is a mild steel door so that one doesn't feel claustrophobic when one is inside. There, I was trying to myself go up that ladder and taken this picture from inside. It's like walking up a very narrow and deep tunnel, and with just some light coming through the roof above. Yeah, so 8.75 meters, almost 9 meters you climb. It's like climbing 3 floors, not a very much steep climb. And there you see the tank finally taking shape. You know? There you have these stiffeners up there, and from outside they look quite thin, not more than 4 centimeters, 40 mm in thickness, and they go up straight. It was faultless execution by Prakash Nagnath, and I must congratulate him for doing such a wonderful job there. Very controlled, very systematic, and there you have the final result of the elevated tank. Uh, and just for interest, on the left hand side, the small tank here was what was being used earlier, because the toilets were at that same level. And people who are familiar with the cantonment might know that there used to be 24 hours water supply till very recently. But now in the last 3-4 years, the 24-hour water supply is not possible. And that's why they're having to do this exercise of doing this water tank up here. So it's in the, can you go back? It's in the, you can say, the southeastern corner of the site, just a little distance between the building and its compound wall. And we have used that space to actually accommodate this. And in the next slide, if you go to the next one, it's not visible from anywhere. So one has to really make an effort to see where the tank is located. And there you just see about the little bit of the roof of it. And located close to the bathrooms and in a Vastu correct location and all that. Next. Now we go to the next tank, which was actually the effluent treatment or sewage treatment plant. And one Mr. Prasanna Jogdev of Lemnion Biotechnical Engineering, he suggested a duckweed system-based sewage treatment plant. And he gave us the system components in which duckweed is actually put into the water, and the costing, because we had to compare costs, the irrigation requirement or the solar pump requirements, and the operation and maintenance costs. So this was 36,000 per year, which is partial salary of a non-skilled labor. And only one disadvantage was the higher area required. So there was no operating power or chemicals, which is typically used in a filtration plant of the typical municipal corporations or any other areas that I've seen. And the non-skilled labor can do this job. You don't need very skilled people. Next. And this is a conventional MBBR says supplies, erection, testing, commissioning, kind of a costing. And there you can see the costing went up to 2,51,240 per year. So it was quite an expensive thing to use a conventional thing with sludge drying beds, MBBR tanks, or chlorine contact tank, the typical kind of water treatment that is done by municipal corporations. And a lot of people from the irrigation are there in the Ferrocement Society, and I'm sure they're much better experts at all this than what we got. But here we have the whole thing, which is summarized in the next sheet. Can you go to the next one, please? Yeah. So the capital cost, the operating cost, and the duckweed system advantages. So you can see there that the duckweed system offers a 86% savings over the yearly cost, and in the capital cost there was a 28% saving. So obviously they went in for the duckweed system, and the owner, being a very animal conscious kind of lady and environmental conscious lady, she went in for this. duckweed system. Next. Now let's see what the sewage consultants, an old friend of mine called Mahendra Kondekar, MBK Consultation is his logo there, logo type. And there's a long kind of tank. It's about 26 meters long, which he had designed, and about 4.5 meters wide, divided into three compartments. The red one that you see is the long tank, where different kind of stages of that whole process take place. And this is like an initial sketch design that he had given, a layout of 7.5 kiloliter STP for roll stone. That's what it says. And a tentative section was drawn. And these two tanks at the beginning, small tanks on the right and the left, these are the treated water tank and the primary settling tank. Those are the kind of two additional tanks at the ends that were given. And having gotten this kind of a rough sketch from him, we had to then detail it out and make an architectural drawing of it. Next. There you see there were servants' quarters surrounding it, and there's a compound wall with the Bhairova Nala road going outside the compound wall. And we had to fit this into that space. There were trees also, and the owner lady was not very happy to take off one tree. It was a suba babul tree, and we had to tell her that it must go. If required, plant it somewhere else. And we had to fit in that whole tank in this place. So it's showing the location of the sewage treatment plant. The next slide shows you a more detailed picture of it. Next. Yeah. There you have the structural design given by, again, Mr. Gaukar. And you see the thin kind of rib slab with all these ribs at the bottom down here going into the yeah. Sorry, this is a plan which shows the ribs in the vertical stiffeners for this long tank and also these two smaller tanks. So this is a kind of a ferrocement tank that was designed for this purpose, and that is the section which shows you a deeper chamber at this part, which is where there is the outlet. This is the initial settling tank at this level, and he fills it up only up to a little lower than the half, which is 600 centimeters. Next. There you have the stiffening details, again drawn up by that trainee from our office. Horizontal stiffeners and the vertical stiffeners all shown in here, plan view. Next. There you see the finer details. Like in the earlier case, these were also drawn to that same scale, where everybody understood what is going to happen at each point in that whole structure. Next. There you see the bottom slab being cast first. It's kind of a bed on which the tank will be placed. Next. During the construction, somewhere in the February of 2019, here you see a completely properly done settling tank at the beginning, the main tank over here. And next. That's a completed tank with after the checking was done with the water filled up to the full capacity. And then later on, this earth was put back, because even though it is underground, one has to first check whether there are any leakages in the casting of the ferrocement that is done, which was not seen anywhere in this particular thing. And so the cost of it, as you can see, I've written it there, 28.53 rupees per liter. Yeah. So it's a 54 cubic meter kind of a water capacity that this whole thing has been designed for, and very properly, proper finishes being executed. Next. There you see some other tests being done on that before the thing went in. The earth was put back. Before that, the stiffeners can be seen on the outside. So what we realize as architects is ferrocement is a material which has a behavior like a timber section or a steel section. And it has got the economy of a steel reinforced concrete kind of a thing. without having the bulkiness of a typical RCC member. And in a place like this, it was very important that these water retaining structures, be it an elevated tank or this ground level effluent treatment plant, needed the kind of material to be used. And of course, it was the whole consultation and the execution was left to experts. Next. There you see a detail of the ribs, the place, the kind of the jalis, the well meshes and chicken meshes properly tied up at all levels. Next, the third tank that I was telling you is a water tank, a ground level water tank that was built. That's a finishing stage where the plaster, outer plaster, is being done for the water tanks. This has also got the horizontal and vertical stiffeners, as you can see here, and the top slab being complete. There was some problems of leakage. You can see it if you go back. There's some little white stains that. No, go ahead. One. There's some white stains which you can see at the bottom here, which were a bit of a problem. But very soon, Mr. Naganath, he took care of that and convinced everyone in the team that it is not a major fault. There's some bit of reconcreting that had to be done, and that was complete. The job was complete. Next. So, Mr. Prakash Nagnath, who is the owner of this Habitat Ferrocement company, the overhead tank, which cost about 13,29,000, and since it is an overhead tank and a lot of the material goes in the support infrastructure, the central column with the access way. So this per liter, if you calculate, goes up to some 235 rupees a liter. Whereas these ground level tanks, they cost around 25, 26 rupees a liter, these sewage treatment plant. So in conclusion, I feel that ferrocement was helpful in reducing cost, making an architecturally elegant structure which is easier to maintain and more eco-friendly through the joint collaborative efforts of the owners, the architect, the sewage treatment specialist, the structural designers, and of course the contractors. So I think this is my last slide.
Thank you, Kiranji, for this excellent presentation. The- First of all, I would like to ask a basic question.
Yes,
Why you have chosen this ferrocement for these works? Of course, you have mentioned during your presentation few advantages of that. But I would
yes.
like to ask you with this angle that what properties are you found most suitable for such kind of construction? Please explain.
The properties of this material, as I have come to get familiar with it and use it in various situations, is one is that it's like a tried and tested material by now, and secondly, though the IS code for it is being developed, but our contractors and structural designers have now gained the confidence and the experience of what this material can offer. The biggest advantage I feel is the thinner sections when compared to any other material. Uh, of course, steel has got much thinner sections than this, but it would be far too expensive to use an exclusively steel structure. So it's a kind of a midway between it. It's a kind of a golden mean between an RCC structure, which is very bulky, and on the other end is a steel structure, which would be very expensive.
Right.
So it is like a golden mean. And as you saw, the 13 lakh rupees and 15 lakh rupees that were used for those tanks, they were found to be very, very reasonable when we compared to similar RCC structures. They were very reasonable as found in those analysis that we have put across.
Of course, these slim sections are more attractive and looks aesthetically very nice.
Hmm.
Uh, how much you found the economy? That means how much reduction in the cost in percentage?
Like you saw, 28% was the economy in the capital cost, as in the case of the sewage treatment plant. Uh, so in the overhead tank, probably the economy was a little higher because had we taken an RCC, one thing, it would not have fitted in that tight location that we fitted in. With so many buildings and walls around, it would not have fitted in that. And then the circulation, even human circulation around that corner of the building would have been disabled. So because of its thinner cross sections and thinner overall sizes, all this was like the inevitable sort of material to be taken in this situation.
Yeah. One last question from my side.
Yes,
Can you say that all these three water retaining structures, for this, you found this material as the most watertight or waterproof? So that property was attracted more in comparison with RCC, so that you can use it more confidently and more comfortably.
definitely, definitely. The water retaining capacity of this material is really very the most attractive thing. And secondly, of course, the economy of it. Somebody has asked me this question: what is the what is storage capacity of the overhead tank? Sunil Srivastav is asking. The answer is 3530 liters, 3,500 liters was the capacity of that overhead tank. Yeah, because that lady has about 8 bathrooms there, and we had to satisfy that water requirement.
This Yamini Deshmukh, she is also an architect,
Beautiful
which
presentation. A lot of details that I could understand, and absolutely fantastic. Thank you so much, sir.
Mr. Piyush, how
Really
do
loved the presentation, sir. It was really interesting and learned really too many things about ferrocement and its working, sir.
Mr. Mohammad Sadiq ji from Bangladesh?
It's a very nice presentation, and I must say it's a very good work because what I believe, if we consider both from engineering and architectural point of view, I think it's a very nice combination of the for fulfillment of the requirement. Yeah,
Right.
But here ferrocement technology is the appropriate technology for actually meeting all the requirements of architectural and structural issues. So it's really fantastic. I liked it very much, and I will try to follow actually this concept.
Hello, Kiran. Good to hear your voice again.
Hello, Owen. Nice to meet you. Yeah,
And it
glad
was
to meet you.
very good to see the work that the utilization for the wastewater treatment. I have never seen that with ferro cement. And hopefully I make it back to India and hopefully we meet
Of
and
course,
perhaps work
would love
together.
that. Yeah.
But yeah, very good, very good. It looked great.
And Dr. Mrudula Kulkarni, I would like to ask you, of course, your opinion about this presentation, but added to that, it's my question to you, how you can introduce some kind of precasting in such structure.
And I could see that it was very excellent finish that could be obtained, and still keeping the thin sections for both the projects. And the symmetry of the geometry was so nicely put up, and the strength of the material, ferrocement material, was utilized fully along with the aesthetics. So it was completely a beautiful structure we could see here. And the question our sir has raised is how we can introduce precasting into it. So actually, for the shaft portion, if we can construct sector by sector or ring by annular rings, and then we can install them, that can be one of the approach. If we want to introduce it as a precast component, if for the construction of water tank, and some other parts also we can consider it to be a precast components. A different thought can be definitely given, but because it is a symmetrical structure, there is possibility that some of the parts of the components can be precast and then assembled together at the site. I was interested in finding out, was there any difference in the detailing where there was opening, door opening at the shaft, detailing for the reinforcement.
Well, there was a kind of a stiffening that was provided, a rib was provided around the door. That is the only kind of a difference that was there. Because I understand your question, because it would be weak, the section would be weak, and
Yes.
especially at the base, where it really needs to be strong. but one has to enter there, So there was a kind of one could not avoid that opening there. But everything was shown previously, and whatever deviations were done, we went back to Mr. Bedasgaonkar, who gave us a revised design for that, and for which we are very grateful, because this happens in a practical situation where the owner says, no, this height is not good enough. You please increase that. And that led to recasting the footings and all that. But I see that there was no compromise in the safety, because in such structure there can be a safety issue, and that was very properly sort of detailed out, understood, and of course tested also later on.
I would like to ask the expert comments from Dr. A.K. Jain, sir.
The presentation was very nice. The work was executed in the manner it should be executed. There is only one point which I want to, which I don't comprehend, because in the last lecture, I think Mr. Ullas Paranjupe said his cost of water tank was somewhere around 4 rupees a liter. Is that correct, Mr. Paranjupe?
Yes, 4 for open and 5 rupees for closed tank.
Yes, for 5 rupees a liter for the closed tank.
And here, but with profit it will go slightly more. But
that's okay. I mean, make it 10 rupees.
Huh?
Make it 10 rupees.
No, it can't be 10 rupees. Of course, if you want to build a bungalow, you will charge 10 rupees.
So, and here the cost is coming to somewhere around 28 rupees.
Yeah, that is huge.
I mean, I don't know. From architectural point of view, it may be acceptable. From Pune point of view, it may be acceptable. But as far as ferrocement is concerned, I think it will need a lot of rethinking on the part of ferrocement people. That there is a huge difference between 28 and 6 rupees or 7 rupees. I mean, that's my off-the-cuff comment. Because the capacity is very small, like 3,500 liters, whereas the capacities which Mr. Paranjupe has made are rather more than this. So that's all. I would not like to make my comments very long, but overall, I'm talking about the ground tank also. If you take the ground tank, I'm talking 28 rupees for the ground tank.
Yes.
But the overhead tank, he is giving a figure of about 200 rupees or something like that. I mean, we design RCC overhead tanks every day, and the costing is somewhere around 20 rupees is the maximum that we go for. Anyway, that is neither here nor there, because he has done it for the first time, and it meets the requirement of the owner, and it meets his tight boundary conditions that he had to face. I think it was a very nice effort, and we must congratulate him for that. That is all I would like to say. Thank you, Mr.
Yes.
Thank you, sir. Thank you very much.
Particularly, he highlighted the cost aspect. Of course, if the owner permits, and the most of the basic difference I found is about its very articulated design of that. If we want to add the beauty, certainly we have to get up some extra money to considering that aspect. But if you purely consider the RCC versus ferrocement, as in the beginning itself, Kiranji has justified that it is certainly economical structure. Okay, we will go ahead. Dr. Divekar, sir.
Very good combination of an architect, a structural designer, and a ferrocement applicator. Wonderful work. In this case, about the cost of that septic tank or say effluent treatment plant, ribs are provided. When large size tanks are provided, ribs are required to be provided, and they increase the area that work that is to be done. Then vertical ribs are also provided, and horizontal ribs are also provided. So that adds to the cost. That is very
Yes,
important. That is
definitely,
why the
sir.
cost increases. For a plain tank or for circular tank, it may be about 10 rupees. But for ribbed tank, for large size tanks, the cost goes due to the area increase due to ribs and the covers, everything.
Right.
Thank
Yes.
you very
Thank you.
much. Yes.
Mr. Padmanabh Leleji, you have built so many structures, with different kind of structures all over Pune and even other states. So how do you find these typical water retaining structures now?
The structure is built very good. I
Mm.
like the structure. Even while that construction was going on, I was in touch with Prakash Nagnath. So we
Mm.
decided many times to visit that place. And we have discussed about it many times. But he has done a very good job. And regarding cost constraint, uh, for every structure and every place, costing differs. In Pune, labor rates are very high as compared to villages. Here, as on today, we are paying around 650 to 700 rupees for a bigari, non-skilled worker. And for the same work in the villages, they are paying 350 to 400 rupees maximum. And in ferrocement, costing depends on the labor cost. Labor cost is very dominant in ferrocement work. So it happens that it affects. In Pune, the cost is always very high as compared to RCC. We cannot compete with conventional RCC. For non-conventional works, definitely ferrocement is cheaper, cost effective.
Right.
That is the most important point, because costing is very difficult to choose, and per liter costing is actually deceiving. We have to work it out on area basis, and that is the major difference. Even in that PVC tanks, we will purchase that Syntex and similar tanks.
Yeah.
Their costing material is same, but they charge on liter basis. That's why that concept has come, charged on liter basis. Actually, it is not logical.
Yes.
Hearing from all the comments of the different experts and their based on their experiences. Now, your concluding remarks.
Probably this is a member for which we are all trying to promote, and we are trying to say that it has got its place in certain areas where it is most relevant.
If you want to make more beautiful, more attractive structures, then the ferrocement gives a good solution and with at ease, because the very unique properties are there as compared to RCC with the ferrocement. And Kiranji has showed us by constructing a beautiful structures, of course, including water retaining structures, some more building parts and even the entire buildings too. So I appeal to all the engineering fraternity as well as the architectural fraternity to come together, make use of this excellent ferrocement technology, and of course to spread it towards the newcomers, right up to the engineering students, the architectural students, and make it in practice. So with this, I thank you all the participants and all the experts for their contribution and their comments. And finally, the speaker, Mr. Kiran Kalamdani. Thank you very much and good night to all.